All right, Nimble Raven, number 1 in, followed by Witty Mouse. It's great to have everybody here, and we are going to start in about 9 minutes. So get logged in, get comfortable, get a sip of water or something that'll help you. And I think we have it's like 12, 13 questions today that all have the word virtual in them. Now, it's not covering every possible technology in Cisco land that use the word virtual, but sorry, Frosty Master. I got to be pretty quick in the day to get the first one in, but I'm glad you're here. Fantastic to have you here. So the word virtual appears lots of places, but these are going to be CCNA focused topics like Hsrp and FHRP with their virtual IP addresses, a switched virtual interface, a virtual private network. What else? A couple other times. So I made everything surrounding the word virtual, and hopefully we'll have a lot of fun together. Solid Shadows in the house. I see Blendinator's in the house. Good to see both of you. Kelphil's here. Jesus is here. ViceNet is here. All right. Nick003 is here. James Casey's in the house. Good to see everybody. All right. I love how Nick, you just put it out there. I'm Dazzled Sable. I don't mind telling everybody who I am. Way to commit. Love it. Everybody's in a safe place here. All right. Shadow's taking his first shot at NRC tomorrow. That's awesome. Good luck. All right. Austin, Texas. ViceNet, great to have you here. Hello, Mark. Hello, Sid. There's Dan, aka Blendinator, wishing everybody good luck with the super sticker. I appreciate the community and the support and the help that we're all giving to each other. It's fantastic. If you're brand new to the channel, hey Max, if you're brand new to the channel, my name is Keith Barker. I have been working with networking and IT for a little over 30 years. Started my IT career in 1985 when the PC was fairly new, and love it. Have always loved it. And my goal is, even though I can't have a direct personal relationship with everybody who's on the channel, I do have a really great relationship with a nice handful of people. But my goal is for me to be a resource for anybody who wants to refresh on the fundamentals or to start with networking and learn the fundamentals. And my goal is to provide you a quick ramp up in that process. It'll change your life. It's changed my life. I remember times in my life when I didn't know anything about networking. Nothing. I still remember when I didn't know anything about virtualization. Like, how does that work? And what is that all about? Which is yet another term that we're going to talk about today with the word virtual. So anyway, I'm grateful for the opportunity to get to, have some contact with many of you and provide some service for many of you. And I appreciate the community. We also have Discord that we have a server there. We have over, I think, 10,000 people there now, too. So if you are studying for a CCNA, here's a couple recommendations I would have for you. Number 1, get a course. It could be a book. It could be a video series, something formal or structured that covers in order all the parts of the blueprint. Secondly, prepare yourself to lab almost everything up. It's free. NetAcad. That's Cisco's Network Academy. It's free to sign up there. You can download the emulator called Packet Tracer for free. Actually, it's a simulator, but it covers almost all the topics you'd ever want to practice with, and it's very quick and easy. It doesn't cost a dime. So get a course, get the emulator or simulator from Cisco, and then third, put your head down and go to work, and just keep on working. This is a lifelong opportunity to get in the world of IT and keep learning and keep getting better. And I remember when I was working on my first CCI back in like 2000. I got my first one in 2001. And I spent about 8 months, 3 to 4 hours a day, 4 to 5 days a week, just studying and prepping and labbing for my CCI. And I did it. I was able to pass it the first time, but it was only because I spent 8 months doing that. And it's amazing how much I keep on learning every week in the well, let me get back to my point. So my point was, if you're studying for your CCNA or you want to reinforce the fundamentals, join us, put it on your calendar, schedule the time every Saturday at 10 a.m. Pacific on my Discord server, our Discord server. It's free. We have an office hour where you can come and bring your questions of what you're studying, or can you help reinforce the concept? And it's an open forum to ask questions, primarily of me, but this Saturday I have another commitment, so Dan has volunteered to go ahead and moderate. So thank you, Dan, for that. Also known as Blendinator here, or Troubled inside the Discord server. So thanks for that. And then every Sunday at 11 a.m. Pacific, we have a quiz like this one. So I would encourage everybody, if you're serious about, taking that next step or reinforcing the fundamentals, schedule those 2 blocks of time. They are both free, and we are happy to help. And we're glad that you're here, part of the community. All right, let's see who else is logged in. All right, Sid is here, Max is here, Abdul Karim. My accent and pronunciation probably isn't great, but it's great to have you here. Dime is here. Eduardo is here. Dante. Oh, tested October 30th, CCNA. All right. Dante, my recommendation for you is about at least a week before you take your exam, go through my playlist on YouTube, which is a recording of many of these quizzes. We've been doing this almost 2 years now. And I've got 50 or 60 that I've kept in a playlist that you can review and go through. And the secret is to go through the questions, pause it before you see the answer, and then be really honest with ourselves and say, do I know why this is the right answer? Do I understand the technology? If you don't, spend a little more time studying it, but that's a great way to help verify. All right, and Kaiser is saying I passed my CCNA on Thursday, and Kaiser is still here with us today. Awesome. Oh, you're so welcome for the quizzes. Big part of my success. Oh, by the way, I'm Joyful Cat. Let's see if I make the podium. Well, I'm rooting for everybody. And Kaiser, I'm so proud of you for putting in the time and the effort. This life we have is short. I mean, at least in my generation and the generation we're currently in, I'm probably not going to make it past 100. So, like in 15, 20 years from now, that may not be true for other people. But for me, it's short. Let's live this life. Let's make meaningful relationships. Let's help our brothers and sisters. Let's not take crap from anybody. At the same time, those are not mutually exclusive. We can, put our heads down, do great work, improve our lives. Don't take a lot of guff from too many people. I'm often motivated, by the way, by individuals in my life. And I have several examples who've said, you can't do that. I'm like, oh yeah? Watch me. Like my first CCI, I had so many people, you can't get a CCI, you can't get it done. And you can. It's just a matter of time and effort and consistency. Also being kind to yourself at times. Be kind to yourself if you have fallen down and you're getting back up. Be really kind to yourself. But if you're not doing what you know you need to do, don't be so kind to yourself. Like, use some anger. I mean, if you get angry because you're not doing what you need to do, fix it and do it quietly. Don't waste the energy griping to the world. Just shake your head, get the dust off, stand up, start walking again. Life isn't fair, never has been. However, the harder we work in the direction of where we want to be is very likely to yield results. Maybe we're not going to be astronauts. Well, I'm not studying to be an astronaut, but maybe we're not going to be some lofty, amazing goal that we want. But I can tell you this, the person who takes steps in the right direction is going to be better off than the person that doesn't take the steps. All that to say, I'm glad you're here. Welcome to the community. If you're brand new, my name is Keith Barker. We're going to start here in just a few moments with this quiz. And Kaiser, congrats. All right, Daniel, I just passed the CCNP Encore exam on Friday with help from CBT Nuggets videos. Daniel, that is a tough exam. Congratulations. That is tough. I walked into that exam. I heard from a friend, another CCIA, it was easy. So I walked into that exam. This is last year, whenever it was. And I took it. I thought, man, they're asking stuff from all over the board. They really want me to know this stuff. And some of the stuff I can't tell you what it was, but there's a few technologies that I hadn't seen in like a decade. And they were on that exam. I was like, wow, man. All right. Balahi is here. Hello, Balahi. Welcome, welcome. And let's see here. Also, if you do me a huge favor, if you've already logged in, and you haven't already done so, just type in the location of where you're taking this exam from. It could be the state or the city or the country or the hemisphere or the continent, whatever you want to put. But it's always fun for me to see what an amazing international audience we have. All right, Scorpio's here, Emmanuel's here. CCNA certified, yeah, says Emmanuel. Awesome. All right, and S Smooth is asking, ISIS, that is not part of the CCNA. However, I would recommend for everybody to be aware of how administrative distance works, and I'd also encourage you to be aware of what the administrative distances are for BGP, internal and external, EIGRP, ISIS, RIP, OSPF, static routes, and if I didn't say EIGRP, that too. Wow, Kenya, France, Texas, Belarus, Bulgaria, Norway, Kenya, LA, Poland, Sudan, Greece, Moscow, Nigeria, Oklahoma, Armenia, Connecticut, Netherlands. Oh my gosh, I'm just so happy to have everybody here. Venezuela, Grenada, Maryland, Canada, Morocco. Oh, I'm so pleased. I'm so tickled. Thank you, everybody, for showing up, and make this part of your regular schedule. It's only like an hour every Sunday, sometimes a little more, sometimes a little less, and it's a great refresher. Help you remind yourself how things work. And Ethiopia is in the house, India is in the house, Congo's in the house, Colombia. Welcome, everybody. Let's get this party started. Here we go. My name is Keith Barker. It's great to have you here. This is tech for the CCNA that includes, in some fashion, the word virtual. And here we go. Here's question 1. It is multiple select. A switched virtual interface, SVI, on a multi-layer switch may be used for what? Nice work. So one of these questions that I'm putting up here, a lot of them, and the way Cisco was going to ask you as well, is they want to know, do you understand the technology? And so if somebody knows what a switch virtual interface is, which is a layer 3 logical interface on a multi-layer switch that has an IP address, either IPv4 and or IPv6, and that's what it is. So if we know what that is, then we could say, well, that could be used for management, because I could have a switch here, and we could remotely connect to that IP address for management. In fact, let me show you a quick example of that. Let me go ahead and bring out. Here I have a little PC. It's virtualized. And I'm going to connect to, I'm going to telnet. Ooh, Keith, you're using telnet. Before I telnet to that switch, let me ping real quick, just to make sure I have connectivity. Ping, if I don't, this will be a very short demo, 2.0.254. Yeah, that's working. All right. I'll do a Control-C to break out of that. And let's do a telnet over there. So right now, I'm telnetted to this switch, and I'm logically connected to that switch to one of its SVIs. So whether it's a multi-layer switch with routing using those SVIs, or a layer 2 switch that still has an SVI for management, that's what it can be used for. So if we do a show IP interface brief, it shows right here that I'm connected to a logical layer 3 interface, a switched virtual interface, It's called VLAN 10. Not to be confused with the actual layer 2 broadcast domain called VLAN 10, which this SVI supports. And there's its IP address. And then we do a who or a show users. I would also do it. This is showing that logically I'm connecting to this device, to its IP address on that layer 3 interface, logically through VTY line 0. All right, that's fun. Okay, so let me go ahead and remove all that. Boom. All right, and let me get that out of the way. And so it can be used for management. It can be used for IP routing if we have routing enabled on a multi-layer switch. It can use the SVIs for routing purposes, and clients could point to that SVI, the IP address there, on that local VLAN as their default gateway. Nice work. We're off to a super strong start. Bronze crab, purple sphinx. It's fun for me to say that word. Diplomat Raven, dazzled sable, and epic glider. Also, I was looking at the comments regarding where everybody's coming from, and I didn't have a chance to read every possible location, but I'm looking at that list, and if I didn't mention your country, state, or location by name, just realize there's just too many for me to do that. But I'm glad to see you all here. All right, here we go. Question 2 of 15. Which IPsec protocol provides privacy and encryption for a virtual private network? And we got a question saying, was that the Ubuntu bloop sound? What happened in the background? I had this computer here, and I mistyped something. I had to clear it off, and that was a burp came through on the speaker. Sorry about that. But that was from a Linux machine. Okay, it's AES is an algorithm, an encryption algorithm that's used as part of IPsec that provides the encryption of the privacy. So SHA is wonderful. It's a data integrity hashing algorithm. Diffie-Hellman is used, DH is used to establish shared secret keys. And AH, authentication header, doesn't provide any encryption. It just does data integrity, but no encryption. Nice work. Nailed it. Here we go. Question number 3 of 15. With these 3 Hsrp routers, who responds to an ARP request for the virtual IP? All right. I also just noticed that Antonia states, I finally did the exam last Thursday after studying a very long time, and I passed. Congratulations. That's amazing. Fantastic work. All right. With these devices, which responds? Let's take a look at the media real quick. Let me grab a pen. So with a first hop redundancy protocol, the goal is to have an IP address that clients can use as a default gateway, normally handed out. That information, their default gateway would be handed out with DHCP. And they're in Hsrp, which is Cisco's implementation, there's only one device that's going to respond and take care of like ARP requests and forwarding on behalf of that IP, and that is the active router. So if we look at these 3 routers, the active router is not this guy, because he's seeing it somewhere else. Here we go. So the active router is local. That means R10 is the one router in this Hsrp group. This that is in the supporting the virtual IP address, and that's how virtual ties into this question with the virtual IP address. All right, here we go. And Purple Sphinx, knocked out of first place, but Dazzled Sable. You might wonder, well, wait a sec. I'm getting all these correct. How can I not be in first place? And the answer is, the faster you answer correctly, the more points you get. So I would say take as much time as you need. Focus on making sure you understand what the question is, answer as best you can, and then also make a note of where you might need to study a little bit more. All right, here we go. Question number 4. Multiple select. Based on this output that's coming up in a moment, what is true regarding hot standby router protocol? All right. So Arson was asking about more labs. I've got 20 or 30 packet tracer labs of varying difficulty, most of them targeted at CCNA level at thekeithbarker.com. So you can just go download this for free. Fantastic. It's using the non-default priority. So as we look at the output here, the thing is, when I see a question like this, we don't have to worry about answering we only have to worry about answering the question at hand. We don't have to worry about all the output. So this says we're looking at standby regarding how it's configured on this sub interface. It's using version 2 of Hsrp. It's group 20, and also the MAC address is going to represent that too. So here, the last 2 characters of the MAC address is the group number in hex. So in hexadecimal, the values are 1, 16, 32, and so for group 20, which is be 16 plus 4 more. That's why 14 in hexadecimal is group. I just totally messed up. So a decimal 20 is equal to a hexadecimal 14. So that's why that's that. Also, that question may come up a little bit more in another quiz question coming up, so we might want to remember that. And let's see here. It has a non-default priority because the default is 100, and it is using the default MAC address. All right, fantastic. Let's see how we did on that. And the survey says, really, really well. Congratulations. Okay, top of the list here. Bold, new, bronze crab, epic glider, purple sphinx, dating lobster. Maybe there's an app for that. I don't know. Daring lobster. Congratulations to everybody who's on the board and still striving your way to the top. Here's the next question. Which cloud model makes the customer responsible for operating system patches on a virtual machine? All right, pretty good. I do want to answer a quick question from the queue, and then we'll continue on and make it a little bit bigger. Somebody asked, they asked, I'll just quote it. It says, Keith, Hsrp is not in the syllabus for this blueprint. Can you throw some light upon the same? Yeah, so right here, this is section 3.5 of the CCNA blueprint, the current one, describe the purpose of first hop redundancy protocol. So we could say for a default gateway, and it's not asking to configure, but as far as a question regarding 3.5, they're very likely going to ask a question about how does it work or how does it operate, and that could include VRRP, which is a open standard first hop redundancy protocol, or Hsrp, probably not gateway load balancing protocol, which is yet another option for that. But that's where this comes from. With the first hop redundancy protocols, Hsrp and VRRP, you should be aware of how they work. And if you have about 10 minutes, you could lab it up and confirm. All right. So having that out of the way, let's go ahead and take this question. Which cloud model makes customers responsible for operating system patches on a VM? Most of you got that right. Fantastic work. Let's talk about why that is. So let's imagine that a customer wants to buy some cloud services. Basically, cloud services is a fancy way of saying somebody else's stuff, right? Their servers, their stuff that they're providing for you, so you can just rent it instead of having to have it on-prem. So let's imagine that this represents networking, and this is, let's call this a hypervisor. And let's call this an operating system, and then we have apps and data and services. So if we wanted to go up, let's say to Amazon Web Services, and we want to rent a whole server, which is going to be virtualized for us, but that whole server, basically, we're responsible for everything for our customer. They'll do the hypervisor and virtualization for us, but we're responsible for all this, including the operating system. So that'd be infrastructure as a service. Some companies, they don't want all that. They may not need all that. They may just want an environment where they can develop software. They don't have to worry about the underlying operating system or anything else. They just want a platform for creating their code. An example of that would be platform as a service. And then some customers may want, I should probably put apps up here. Some customers don't want to deal with anything except for the application, and that's software as a service. An example of software as a service would be Salesforce, where they host everything in the cloud, and all we do is securely connect to it, run the apps, and we're good to go. So in infrastructure as a service, the customer would be patching the OS and working with their system and so forth. In a truly IaaS environment where they're renting logical networks, if you will, up in the cloud. And then platform as a service is less, and software as a service, the customer is responsible for even less. That's a fairly high-level overview of it. So that's how that works, and here we go. First place, Bronze Crab. All right, everybody's doing great. Here's question 6. What type of interface is considered a virtual tunnel interface? Wow, that is absolutely fantastic. A GRE tunnel interface with an IPsec profile. Perfect answer. I'd like to take a moment and show you something pretty darn cool, and that is this. Oh, I have to log in again. Let me log in. This is a network emulation tool called EveNG. And I'll make it a little bit bigger. Burp, 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 burp. Okay, so I just want to give you a quick tip. Something yesterday in the office hour. So yesterday had, long story short, we had an extended office hour yesterday. I had to fix a couple of problems, then come back a little bit late. But as I revisited, we had some questions regarding GRE and IPsec. And I just want to take a moment to give you a little tutorial appropriate to that last question. And that's this. In the old days, we used to have build an IPsec tunnel. I'll build it right here. That would logically connect two places together, like from site 1, let's call it site 1 on the left to site 2 on the right. And what would happen is these routers, if there was a router or firewall, either way, they would identify traffic. We could train them, say traffic from 10.1 going to 10.2, anything. When you see that traffic, Mr. Router, just don't forward it normally, but encrypt it, send it over the encrypted tunnel, which is using AES usually for encryption services, and ship those packets over to R2, who will then decrypt it and then forward it on its way, whether it's to telnet session to switch 1 or going to this PC, whatever it is. And we used to do that with crypto maps. However, if we wanted to run a routing protocol like RIP or EIGRP or OSPF, those are all examples of dynamic routing protocols, and they also all have something in common. That is, they will share routing information with devices that are directly connected on the same network as they are. So the problem with the old crypto map model is that R1 and R2 are not on any common network. They're just taking packets one by one, encrypting them, shipping them over. This guy decrypts it, forwards it, but there's no common network. They can't be neighbors across like the internet with these routing protocols because they have to be on the same network. So we have another solution that's very relevant for you as a CCNA. And let me go ahead and share with you what it is. It is this. Instead of building an IPsec tunnel, we use something called GRE, Generic Routing Encapsulation, and we make a tunnel interface like this. And that tunnel interface, we basically say on router 1, hey, I want to make a new tunnel interface, pick a number between 1 and like 11 billion. It doesn't really go that high, but you create a logical tunnel interface and you say, hey, the beginning of this tunnel, like a tunnel has two ends. So on this router, you say the beginning of the tunnel is here, and the end of the tunnel is the IP address that's reachable over here on R2. And then you give it an IP address like 10.11.11.0 is the network. This guy could be .1. The other end of the tunnel could be .2. And the same thing over here with R2. You create a GRE tunnel. You just say interface tunnel, whatever number you want. Give it an IP address. You specify where the source is. You specify where the destination is. And it logically built a tunnel. So these two routers over this logical tunnel interface, they believe that they're both on the same network, the 10.11.11 network. And as a result, they could build, they could be OSPF neighbors or EIGRP neighbors or RIP neighbors because they logically have this tunnel. But in reality, the traffic that was going back and forth, like the multicast traffic, which MULTICAST, all those routing protocols use multicast for hellos and advertisements and so forth. And so multicast traffic is, when it's sent, it's going to be sent over the tunnel, just basically encapsulated in GRE, shipped over the tunnel, and received to their side. So if you want to have two devices that can run routing protocols that support multicast, we would want to use the GRE tunnel. In fact, you know what? Let's do this. I'm going to take a little bit of liberty here and give you an example. So here is router 1 and router 2, which is, here's router 1 side. Let's do a real quick show IP interface brief. Okay, so right now this has no tunnel interfaces. This is the 15 network, and over on the right there's the 25 network. So if we wanted to create a tunnel interface, it would go something like this. And to speed it along, I'm going to go ahead and just use a little copy-paste action. And copy this, bring it over, right-click, and so we're going to go into configuration mode. I'm creating a new tunnel interface. This is the month and day of scientist, that's his name on Discord, who brought up the question. And so I'm going to create a tunnel interface called 1110. Specifying the tunnel source is the IP address associated with gig 0/1. You could also put in the actual IP address there. Then the remote end of the tunnel is 25222, which is R2's reachable address. And then I'm giving that logical layer 3 network that's going to be accessible on this tunnel interface the network address of 10.11.10 and a host address of .1 with this mask. So we'll paste that in. Boom. And then we'll do the equivalent over on the other side on R2. So we'll make a road trip. So we're going to go to R2 for a moment. And here on R2, boom. We'll just go ahead and, so the address here is going to be 10.11.10.2, and the source is R2, and the destination is going to be R1. We'll click on paste. And because I have a routing protocol running, those guys just became OSPF neighbors across this cloud, which could be across the internet. So if we do something like show EIGRP neighbors, that's not even a command. Show IP EIGRP neighbors. That's more like a command. All right, and so there's our neighborship. And if we do a show IP route, this guy thinks that he is directly connected to that network right there, 10.11.10. And he's also learning routes. The D is EIGRP. There's the administrative distance for EIGRP. And we should be able to reach networks. In fact, this PC here, right here, in fact, let me bring him up. This PC right here, PC1, we're on the 10.1.0 network. We can verify that real quick with IP address. And I can make that bigger. So his IP address is 10.1.0.50, and if we did a ping, for example, over to the switch at 10.2.0. Was it 254? Basically, if I did that ping, that's traffic going from this PC to the default gateway, who's now going to send it over the GRE tunnel to go ahead and reach the switch. In fact, let's do one more exciting thing. This will even be better as a demo. Let's go back to the PC for a moment. There it is. And instead of doing a ping, let's do let's capture this. Let's capture the traffic so I can show you. So I'm just going to right-click in my topology, click on capture. I'm going to capture all the traffic on gig 0/1 here so we can actually see the GRE traffic as it's being sent over the cloud. So I'm going to accept the defaults here. And let's go back to our PC and let's do an SSH, let's do a telnet, because SSH would be more secure. So we'll do a telnet and we'll go over to 10.2.0.254 and we're in. So here, I'm connected to the switch. We do a show run, a few space bars. There's the running configuration on that switch. If we open up a browser, so unfortunately here, let me make this bigger and zoom in a little bit here. In this packet capture, I'll go ahead and click on stop. In this packet capture, it's capturing all the traffic. And look at so here's the telnet piece. This is showing layer 3, which is then pointing to the next protocol of GRE, which then is encapsulated the original packet. And unfortunately, if we're sending it over the internet or any entrusted network, we right-click here and say follow, and just follow the TCP stream. You'll see it's not, what do you call this? Bad news? Yeah, because everything we typed that got sent across the network, even though it was encapsulated in GRE, and even though we can have routing protocols that are neighbors, there's no encryption here. And so we definitely wouldn't want to use insecure protocols like Telnet without some other type of protection. So we'd want to use SSH and protect all this, but this is this is bad news. All right, so let me go ahead and close that. And let me close that. And let's talk about what we would do to protect it. So now we have a GRE tunnel between R1 and R2. If we wanted to protect that, what we could do is we could apply what's called an IPsec profile that says, hey, any traffic that comes in or out on this GRE tunnel, I'm going to go ahead and overlay on top of it IPsec. And so to do that, and it's really easy to do, I did most of the heavy lifting in the background, but if we want to add the IPsec to it, we could do this. Go back to our command line. We'll go to R1. Here in R1, I'm just going to go to the interface. I'm going to specify the tunnel mode, and then a tunnel protection profile called our IPsec profile. So I have the backend stuff is all set up to make that work, but I'm just applying this profile to it. We'll click on paste. We'll go to R2. Go ahead and paste. And that's going to bounce because things changed. And now let's do this. Let's go ahead and let me go back to my window, my computer here, and do a exit. All right, and let's do a capture. So we'll do a capture of traffic on gig 0/1, just as a demonstration of capturing the traffic, which is now going to be encrypted because of the IPsec profile. And Ethernet, okay, we'll let that run in the background, and let's go back to our PC. So at our PC here, if we do that same thing with Telnet, and we're still connected, and we do a show run, all that traffic is going back and forth, but now it's being protected with IPsec. So over here on the left, I'll go ahead and click on stop here, make that a little bit bigger. And I'll make that bigger too. Pop, 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 pop. So now we have ESP. And so effectively this says, here's what the internet sees. They see traffic coming from 15.1.1.1, that's router 1 on the left, going to 25.2.2.2, that's R2 on the right. However, at layer 4, it's protocol 50. So if we look in the IP header, it's pointing to the next protocol, which is right here. Protocol, if I scroll up, there it is. Protocol 50 is the next protocol. And then in that layer 4 header, the ESP header, it has the security parameter index to identify this session, this security association. But check it out. All this other data is encrypted. No one knows. Because if somebody's eavesdropping on the internet or across that network, even though it's GRE traffic, which isn't normally protected, we've added on top of that IPsec with an IPsec profile. So long story short, if you want to use tunneling protocols, you can use things like GRE, so you can get routing neighborships and support multicast traffic. And if you want to protect it, you'd slap on the IPsec for the encryption, as we're seeing right here. All right, so that's a bunch of fun. I mean, I've been doing VPN tunnels for decades, and there's lots of different ways of implementing them. But the key is don't use insecure protocols across public or untrusted networks, because people, if they eavesdrop on it, and there's lots of opportunity on the internet for that, they can see what's actually going on, gather passwords and so forth. All right. Let me go back here and let's keep on moving on. Here is question number 7. What is true about hot standby router protocol on this router, which is R20? All right. It has a non-default priority. The default is 100. This guy's got a priority of 106, and all the others were not true. All right. Nice. Also, there was a question asking about, let's see here. Can you do labs like that in Packet Tracer? Packet Tracer does support basic IPsec. In the Cisco blueprint, in the CCNA blueprint, if we bring it in and we look at, I'm just doing a control F here for VPN. So describe remote access and site-to-site VPNs. Now, when it says describe, that doesn't mean, hey, be able to configure and troubleshoot this. It really does mean describe. Like, what are the options? How does it work? The concepts of it, like a GRE with IPsec or a crypto map, or just the basic concepts and how it works. You can use SSL for VPNs. That's also an option. So Packet Tracer does support, and it's free. So as a recommendation, if you are studying for your CCNA, unless you've got a lot of free time, I mean, just like tons and tons of free time that you don't know what to do, don't bother getting an emulator like EvenG or GNS3 or CML or anything else that's going to take a lot of time to learn. Because what you want to do now is focus your attention on learning the technologies, which you can do for free with Cisco's Packet Tracer. So I almost want to hear nothing at the CCNA level about doing anything except for Packet Tracer. And that's why I have at thekeithbarker.com, I've got 20 or 30 labs, and Jeremy's labs, Jeremy's IT labs, if you Google Jeremy's IT labs on YouTube, he has got a boatload of free labs as well. David Bombal has a bunch of free labs, and also I think he has some other paid options as well. So just focus on practicing and using the best solution that's most elegant. And the best solution that's most elegant for getting the hands-on practice that we need is Packet Tracer for free. Because once you start getting into GNS3 and EVE-NG and CML, it becomes an issue of, how am I smart enough to get this all working right now? And maybe you are, but possibly you don't have all the time in the world to do it. And so my coaching would be CCNA level, stick with Packet Tracer, trust me on this, save yourself hours and hours of frustration and time. And then after CCNA, if you want to move on to other technologies and like professional level and other vendors, then let's look into other emulators such as EVE-NG, which is my go-to favorite these days. All right. But I have licenses for CML, Cisco Modeling Labs. I've got a license for EVE-NG Pro, and I haven't touched GNS3 in a few years because I use the other tools. All right, moving on. Here we go. Epic Glider glides into first place. Congrats. All right, here's question number 8. What type of virtual IP address is provided by a first hop redundancy protocol? Or is it first hop router protocol? Let me look that up. It is first hop redundancy protocol. So it's hot standby router protocol, but the actual category is first hop redundancy protocol. Or if you stick with the acronyms, you're good either way. Wow, I got a whole bunch of multicast. That's super. Let's take a look at I'm always pleased when there's some diversity there as far as answers. This IP address right here, let's see, where is it? Right here. The virtual IP address being provided is 25.22.100. That, my friends, is a unicast address. An example of unicast addresses would be anything in the class A, B, or C ranges, which is, like 1 dot anything up to 223. That'd be the highest end. And then a multicast in IPv4 would be like 224.x. And a broadcast looks like this: 255, 255, 255, etc. So a broadcast at layer 3 equates to a broadcast at layer 2, which is 48 bits on Ethernet. And that would be all the bits would be on there too. So that'd be a bunch of Fs. So long story short, the virtual IP address provided by first hop redundancy protocol is a unicast virtual address that clients are then going to likely use as a default gateway to provide that fault tolerance in case one router goes down, the other one can take over the work. All right. Next question, Epic Gliders, first place. Here's question number 9. Which of the following is an Hsrp virtual MAC address for group 10? I'm going to give you a huge clue here if you'd like it. I'm going to give people who can answer that right out of the gate a chance to answer it. For everybody else, look at the last character. The last character is going to be a hexadecimal representation of the decimal group number. So what is 10, decimal 10 in hex? And that's the answer you're looking for. Last character. Nice work. And Fernando, congratulations on passing your CCNA. So pleased to hear that, and makes my day, really does. I appreciate all the effort. Really, I think for me, putting in the effort and measuring that is almost as important as, the final goal. Because if we put in enough effort, we get 1% better, just a little bit better, keep on pushing forward, and we keep that consistently, we're going to end up in a better place. And congratulations on reaching that goal. That's great. So 65 of you nailed it. Fantastic. Here we go. Next question, 10 of 15, multiple select. Woohoo! Which type of hypervisor runs directly on hardware? All right, fantastic. There was a question in the queue I meant to answer a few moments ago, asking, should a person after CCNA, should they go for CCNP or should they go for DevNet first? What should they do? It really depends on what you... I would personally recommend after the CCNA, go get your CCNP. That really separates that individual from the herd. Also, you're going to learn a ton. And then after you know more about the professional level with networking, including some virtualization in that world, then if you want to automate some of that, then dig into the automation tools like Ansible and other APIs and how those work. But, it depends on if you're going to need them or not. My son is a programmer, and he lives for APIs. It's all he does. Interacting with systems, using software that's calling on APIs, that's all he does for a living. And he knows very little about networking. And me, on the other hand, I know quite a bit about networking and very little about APIs. And normally in a company, especially a large company, there's going to be people who focus and are really great at one or the other. So I don't know if somebody can be really great at both. Maybe Knox Hutchinson. If you're not following Knox Hutchinson, follow him. He is amazing, and he's really good at both. All right. So what type of hypervisor? Let's talk about, first of all, what it exactly is a hypervisor. Let's imagine, let me clear that off. Let me start better. Let's start with this. Let's imagine this is a physical computer. P-H-Y-S-I-C-A-L. All right. And so sometimes this is called a host. So this host has CPU. It's got some memory, it's got some storage, and maybe it has that storage is directly attached or it's network attached or whatever, but it's got those resources. And so on that hardware, what we do then is we run, or one option is to run a hypervisor right here. Hypervisor. So we run a hypervisor, and then that hypervisor is like an environment where virtual machines can be created and run. And so on that hypervisor, which is running on the hardware, it supports virtual machines. So each of these blue rectangles represent VMs, and each of those VMs are going to have a guest operating system. Let's imagine that this one is running Windows Server, and this, that's a terrible color. I mean, that's all right. And one is running like Linux and whatever you want to run on there. So they're running a guest OS, and then the applications as well that are on that. Those applications could be virtually anything. And so that's an example of a type 1 hypervisor, which is a hypervisor that runs directly on the hardware. So one example of a hypervisor that runs directly on the hardware that many companies have on-prem would be something like this. This is an example of, here's our host, that's our physical hardware. This is running ESXi from VMware. And in the cloud, Amazon Web Services have their own hypervisor functionality. Google Cloud has their own hypervisor services. Microsoft Azure has their own flavor of hypervisor, but the concept is the hypervisor that runs directly on the hardware and then provides the environment for the VM. So over here on this current ESXi host, which is running VMware ESXi, it's got this virtual machine, which is currently running, and it's got EVE-NG Pro. That's where the funny thing is, to me, is that this little VM right here that we're demoing on, this VM, so it's nested. So we have the physical host running the ESXi hypervisor, which is running these 2 VMs. And then within this VM, which is EVE-NG Pro, it's running a whole network environment, including additional virtual machines. And it's using a technology in this example to do that called containerization. And this is an example of a Docker container inside that virtual machine that's actually providing this little emulated PC that we've been playing with. It's also providing all this as well. So everything you see here, including this little virtual machine, that's all running in a virtual machine. That's all running on this hypervisor in a rack right behind me. Okay, so that's fun. And let's go back here. And also referred to as a bare metal hypervisor. A type 2 hypervisor, just to close out that conversation, would be like this. So here's our hardware. Sometimes I like to call that a host. And on that host, we, instead of running a hypervisor directly in the hardware, we run an operating system like Mac OS or like Windows or like Linux. And then inside of that operating system, we run an application, lots like word processing, spreadsheet, games, whatever. But one of those applications that we can run is referred to as a type 2 hypervisor. So a type 2 hypervisor runs as an application as on a machine that has its own operating system. Then we have virtual machines that can be created in that space. So examples of this would be VirtualBox, and also VMware Workstation. They have a program you can buy that runs on top of the OS and still allows you to create VMs, but you have the OS be underneath it all, supporting the physical hardware. Okay, so type 1 over here on the right, bare metal hypervisor. Type 2 over here, running on top of some type of OS, not directly on the hardware. Great work. Here we go. Moving on. Epic Glider is still staying in first place. Nimble Raven, Bronze Crab, Joyful Cat, meow, 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 and Balanced Panda. All right. Here's question 11. Who could provide an Hsrp virtual IP as a gateway for the PC up in the upper right-hand corner right here? Looking for one answer. All right. I had somebody ask about my son's YouTube channel. He is one of the most amazing programmers and developers I've ever met. He is not quite 30. I think he's approaching 30. And let me grab that link real quick. And he makes videos he's an incredible musician too. His brain just works on all firing on all cylinders. Let me go ahead and post that link if you have any interest in that too in the chats. Paste. And there it goes. It's Poliano. Let me give you a little video or a little preview of that. Looks like this. It's really quite amazing, his videos. He has I think it's like a Raspberry Pi that he has programmed to light up the keys as they're played, and then in post-edit, he adds on the additional flavor, the additional fun. And let's take a look at how he's doing. How is he doing? He's doing pretty good. So we go to videos, and we go to, wow, look at that one. That one has 188,000 views. All eyes on me. Wow. Anyway, I'm so proud of all my kids. I've got 7 kids, and they are all my favorites. Yes, I tell each one of them when I'm with them privately, you're my favorite. They're all great, no doubt. Okay, so, and for this question, who can provide an Hsrp virtual IP address? Any layer 3 interface on a router or multi-layer switch could be an Hsrp active device. And so for this PC, that could be this layer 3 switch here, multi-layer switch, or because it's a trunk, a layer 2 trunk, it could also be switch 2. So that's why I'm looking for switch 2 or switch 3 as the correct answer. Also, right after this, I've got a few minutes. I would love to hang out in the Discord server. So if you have questions about any of these questions or want some clarification, come join me just afterwards in the Discord server. All of it's free, and I'd be happy to chat with you. We'll just hang out in the CCNA chat room and take your questions if you have them. All right. Here's question 12 of 15 with hot standby router protocol. Which IP address is used for the client default gateway? Oh my gosh. There's a lot of Hsrp in this quiz. So I put these together last night, actually yesterday afternoon, and I may have been a little bit heavy on Hsrp, but there's probably a good reason for that. All right, nice work. Also, Brandon, congratulations on your job as a NOC engineer. And also thanks for the kind feedback on passing the CCNA. I'm so pleased. Onward and upward for all of us. And yeah, the virtual IP address is used as a client default gateway, and that's why Hsrp is there. All right, question 13, we're nearing the end. How do you see the virtual IP address? Oh my gosh, more Hsrp. So if you're not yet studied on Hsrp, my apologies, but it is definitely one you want to be aware of for CCNA. Although the blueprint says, describe the purpose of a first hop redundancy protocol, I would encourage you to do a couple of my labs and take it to the next step. Just practice it. All right. Now, if you've been with me in the office hours and you've been with me on my live streams and such, and you know that I don't have every single command memorized, but I do have a very good general understanding of how the protocols work and also how to use context-sensitive help. So it isn't as critical like 2 decades ago or even a decade ago with the old CCNA. It was like, okay, do you memorize all these commands, exactly the commands? And now it's more of, do you really understand how it works? And so it feels a lot less like a memorization of what is the exact syntax. But something like this, if somebody has labbed this up a few times, you know you're going to remember show standby because you've done it. And so maybe the first time you practice with it, it's like, what's the command to see the standby information? And then you look it up or you do a question mark, you see it, and you do it a couple more times, it's going to come in helpful. Now, let me share with you the reality of this. Knowing how these protocols work is going to be super helpful when, in a production environment, you have to solve a problem. Something's not working like it should. Well, how's it normally supposed to be? What's different? What changed? And so all this is leading to enhanced skills that people will pay you for because you have a job that needs them. And am I going to have a job, Keith, that has all 6 domains of the CCNA that I need to know all the time? No. But by George, you're going to have 2 or 3 that are used all the time, like routing and switching very likely in a networking world, and IP services and security all the time, all day, all night. You might not have to cable networks. You know, you may not have to implement a 3-tier hierarchy or do a spine leaf architecture because it's already in place. But most of the other stuff is very, very useful on a week by week by week basis. All right. So show standby. Nice. Okay, I think we're rounding the corner here. Here's question number 14. What is true, my friends, regarding a functioning HSRP group with these routers? 3 routers to be specific. Dan, I agree. This is a tricky wording here. All right, so I agree. This is a little bit tricky, but here we go. So if we have a network segment like there, that's how an old person draws a network segment, and then you have. I'll just draw one PC right there. PC representing any networking device as a network interface card that's going to be on the network. So this could be a printer, it could be a mobile device, whatever. Well, in this case, it's wired, but the same concept would be for wireless as well. Then we have 3 routers. We have 1, 2, and 3, and they're all part of the same HSRP group. And the virtual IP address, let's say it's 10.9.8.67. And so we have a DHCP server somewhere or a DHCP relay, either way, that's handing out IP addresses to clients. In addition, it's handing out the default gateway. It's going to hand out that IP address. So which of these 3 should actually respond to IP addresses, like do an ARP response and so forth regarding this IP address? So the PC does an ARP request, say, hey, this is my default gateway. I need your layer 2 address so I can forward a frame. It does an ARP request. It's a broadcast. They all see it. Who responds? So as far as support, I agree, tricky word, but only the active HSRP router is going to support or answer that call for the layer 2 address. So let's say R1's active. So R1 would respond to that ARP and we respond with the virtual MAC address associated with that virtual IP address. And then if router 2 is the standby, great. And then if router 3 is neither, he's just waiting in the wings for somebody to fail. So if the active goes away or fails, loses the link, then router 2 would go active. And then 3, which wasn't even active or standby, it would then go standby. So with HSRP, there's exactly one and only one active router for a given subnet at any time. And then there's only one standby at any time. And if you have more than that in a group for the same exact subnet, they're just waiting in the wings in the event they need to get called on to step in and become standby and or active if there's a catastrophic failure. Most of the time, you're not going to have more than 2. Okay. All right. Monica, welcome. And I think we have one more question. Awesome Shark, Nimble Raven, Epic Glider, Daring Lobster, and Joyful Cat. Meow. All right, here it is. Last question. What is a hypervisor? The faster you answer correctly, the more points you get. Go, go, go. All right. Look at that. Amazing. No comment required on that, except for way to go. Let's look at the podium. Congrats, everybody. Thanks for being here. Drum roll, please. And that's why the shark is awesome. Nice work. Let me get a little bit of feedback. But here's our toughest questions. Out of all those questions, which I think was like 15, these are the 3 toughest that were answered. 11% correct, 19% correct, and 22% correct. And not bad. Especially this one is like, wow, all these things in the topology, I only have like 90 seconds to think about it. So that's a given. We're going to push that one. Don't feel bad about that one if you didn't get that right. So here's what I'd love to do. Let me get some feedback from you. And also, I'm going to hang out in the Discord server for a few moments. I'll post a link there in the chats here in a few seconds. There's also a link in the description. We'll be in the CCNA voice room. I'll leave my quiz engine open if you have questions on that. I want to congratulate everybody who's taking effort and spending time and effort on studying and getting better. I've told people, and I believed it, and I've experienced it in my own life. The better your knowledge and skills regarding networking and IT, the better your quality of life can be as a result. And it doesn't matter where you're starting, you can improve and get better. And it's just a consistent effort. Enjoy it too. Have fun along the way, but we can just consistently get a little bit better and a little bit better, and eventually have success, and then just keep on moving it forward. So life isn't fair, never will be for anyone. Some people have less advantage than others, and my goal is to help everybody who wants it, to help them improve just a little bit, make a small difference, and improve their situation. All right. Thanks, everybody. I'm going to go ahead and give you some sign-off music, and I'll post that link here in a moment for the Discord server, and then I'll be in the Discord in the voice chat room. I would just ask, if you join us, if you're not going to be chatting, just mute your mic. And if you want to chat, just unmute it and have at it. All right, everybody. Thank you very much. Also, a heads up and a thank you for Dan for next Saturday, who's going to be moderating the office hour for me. I've got another commitment that's going to have me in an airplane at that point in time. Otherwise, I'd be there. But we'll also have another quiz on Sunday. So schedule 10 o'clock Saturday Pacific time and 11 o'clock Sunday Pacific time. And let's enjoy this time together. All right. Thanks, everybody. See you in Discord or in the next live event. Bye for now.